Hi children, how are you? I hope all are fine. Yes, very good. Okay. Now today we are going to see about in the periodic classification of elements in metallurgy topic. Okay. In our last class we have discussed in the periodic properties. So the periodic property is atomic radius, ionic radius, ionization energy, electron affinity and electron negativity. So in these properties, in along the periods and groups is increases or decreases in the atomic sizes. Okay. So today we are going to discuss new chapter of metallurgy. So already learned in previous class in 8th or 9th about the metal and their properties. So metals, luster, density, malleability and characteristics. We already learned metals in the previous class. So now we are going to discuss from where we get metals. Okay, where we get metals, then how we collected that metals, so that we are study the metallurgy. So what is metallurgy? The process of extraction of metals from their ores. Okay, what is metallurgy? The process of extraction of metals from their ores. Where we get metals? We get the metals from earth crust in natural. For example, seawater. So in the seawater contains many salts like sodium chloride, magnesium chloride. Okay, sodium is simple is Na, magnesium the simple is Mg, chlorine the simple is Cl. So the magnesium chloride and sodium chloride. From the sodium chloride we collect the sodium metal. So in the same thing, the magnesium chloride we can collect the magnesium metal. So the process of collecting process. Then how we are collecting the sodium from the sodium chloride is known as metallurgy. Okay, so next one is what is ores. What is ores? The most of the elements all will not get in free state. So all the metals get in free state. Example, gold, silver, platinum. So in the sum one of the metals we get in free state. They have very less reactivity like gold and silver is pure state, but most of the element can be available in state of combined. We getting combined state. Okay, we getting combined state. For an example, aluminium. So the aluminium is combined with oxide. So all of you take page number 113. So in the table 8.1, the types of ore. So this oxide ores, carbonate ores and halide ores and sulfide ores. So 2 or 3 metals combined state is the ores. Okay, so for example, aluminium. So aluminium is combined with the oxide. So the first one oxide ore is bauxite. So the bauxite formula is Al2O3 and 2H2O. So in the aluminium is combined with oxide ore. Then the same thing copper. So the copper is combined with the sulfide ore and then oxide ore. So the oxide ore is cuprite. Then this is combined state. So in the next one, what is minerals? The elements or compound of the metal which occur in nature in the earth crust are called minerals. Okay, what is minerals? The elements or compounds of the metal which occur in nature in the earth crust are called minerals. The minerals from which the metals are extracted without economical loss are called ore. Okay. So for example, aluminium can available in mostly in the earth crust. So we can collect the minerals aluminium in many kinds of minerals to get in aluminium. But the bauxite, if we collect the aluminium, the bauxite it gives very loss in economically. So all ores are minerals, but all minerals are not ores. Okay, so the all ores are minerals, but all minerals are not ores. So the collected the metal from ores. So the collected metals from ores. So the extraction of metals depends upon three steps. Extraction of metals depends upon three steps. So the first step is concentration or separation of the ore. The concentration or separation of the ore. Then the second method, the second method is protection of the method. Then the third method is refining of the method. So see about in the first method, concentration or separation of the ore. So we can collect the ore from the earth crust. Then it contains many impurities. So the impurities like sand, crystal and small rocks present on the ore. The impurities like sand and clay are called gangue particles. So the gangue particles is impure metal. Ore is pure metal. Okay, don't forget children. Ore is pure metal. Gangue is impure metal. So the impurities like sand and clay are called the gangue. We have to remove this sand and clay from the ore. So that process is known as concentration or separation method. Okay. So the concentration process is depends upon the physical methods. Four types of physical methods. There are four types of physical methods. First one is hydraulic method and gravity separation method. Then magnetic separation method. Then fourth flotation method. Then chemical method for leaching process. Okay, these four kinds of metals is concentration or separation ores. Okay, so the first one is the hydraulic wash or gravity separation method. This ore can be made into fine powdered. It contains the slope surface and the powdered is drop on the surface. Okay, the powdered is soft on the surface is the crushed ore. So the crushed ore is the fine powder of ore. So it poured into the water. So the water is poured out and the slope is the impurities is the lighter weight, is the lighter in weight, and then the water is poured out. So this method is hydraulic wash method. This is simple the based on the water method. So we can do that concentration by washing method. Then when it is possible, when the impurity is lighter weight particle, this method is possible one. Next one is the magnetic separation method. So the magnetic separation method, the crushed ore is placed over the conveyor belt. So all of you see one of the conveyor belt, and the belt is attached to two metal wheelers. So the one metal wheeler is magnetic wheeler. Okay, so the metal ore is placed over a conveyor belt which rotates around two metal wheels. So one of the wheel is magnetic. So the magnetic particles are attached to the magnetic wheel. Okay, then the separately the apart from the non-metallic particles. So one is non-metallic particles collected the particle, then another one is the metallic metals is collected in the other beaker. So in this method is magnetic separation method. So the magnetic properties of the ore from the concentration of separation method. So the ore or the gangue is magnetized. So the example ore is tungstone. So tungstone formula is SnO2. The Sn symbol is tin. The tungstone formula is SnO2. is the tin stone formula. The ore is tin. Okay, the ore is tin, pure metal. Okay, then in the next method is the fourth flotation method. Most probably this fourth flotation method can be applicable for sulfide ore. Okay, for sulfide ore. So the sulfide ore is made into fine powder and it is collected that container. It consists of water. Then compressed air is sent into water. Then add the container, then add the pine oil and add the sulfide ore. So in this method passed with a current is compressed air. Okay, so the passed with the current of compressed air. So the fourth is formed. Further was the fourth, the metal is collected, remaining the gang like sand and clay particle present at the bottom of the container. Okay, bottom of the container. The ore is vectored by the oil and gets separated from the gang in the form of fourth. Okay. So ore is lighter particle, lighter weight. It comes on the surface with the fourth and the impurities are left behind. So the ore is zinc. The example of the compound name is zinc plant. Okay, zinc plant is the sulfide ore. Okay, is the sulfide ore. Zinc is Sn. Sulfide, in the presence of sulfide, simple is S. So in the zinc blend, the formula is Zn-S. The last one, chemical method or leaching. So this method is employed when the ore is in the very pure form. So in the leaching process is used in the extraction of substance from solid. Okay, from solid. So some ores of metals in oxide ore, carbonate ore, halide ore and sulfide ores. Okay. So in the next one, so in the more reactive metals and medium reactive metals and less reactive metals. So in the more reactive metals is sodium, potassium, calcium, magnesium and aluminium. So Na sodium, K potassium, Ca calcium, Mg magnesium, Al aluminium. So these metals are more reactive metals. Then the medium reactive metals. So in the example is zinc ion, lead, copper. Zinc Zn, ion Fe, lead Bb, copper Cu. Then less reactive metals, silver and mercury. So silver Ag, mercury Hg. So the more reactive metals is electrolytic reduction of metal oxide into metal. Okay, metal oxide in, so in the metal is react in the presence of air to converted into metal oxide. Okay, so the metal react in the presence of air, so the metal is converted into metal oxide. So in this more reactive metals, the reaction is metal oxide into metal. Okay, then the medium reactive metal is the chemical reduction of metal oxide into metal using coke means carbon C. So in the next one is the less reactive metals in the thermal decomposition of metal oxide to metal. The thermal decomposition is the heating process. So in the thermal decomposition of metal oxide into metal. So what is metallurgy, and then the concentration or separation types of ores metallurgy. So the first method is hydraulic wash method, then the second method is magnetic separation method, third method is fourth flotation method, and fourth method is chemical leaching method. Okay, so in the next one, the properties of metals. So the properties of metals is physical properties and chemical properties. So the first one, physical properties. So in the physical properties means one metal, you see the structure and hardness and melting point and boiling point. So these are the physical properties. So the first one, physical state. So in the physical state, all minerals are solid in the room temperature. This metal is gypsum. So the gypsum metals from the earth crust in nature. So in the physical properties, so this metal are solid. Okay, this metal are solid at room temperature. Okay, at room temperature. Then luster. So in the luster means the metal possesses a high luster. So in the luster means luster is the property of minerals that describes how light is reflected. Example, the metallic and waxy and silky and dull are all types of lusters and all types of lusters. Then hardness. So in the hardness, most of the metals are hard. Okay, most of the metals are hard. For example, limestone, gypsum and tungsten. So the most of the metals are hard and strong metals. So exception of sodium and potassium. So sodium and potassium can be cut with a knife. Sodium metal in the presence of sodium chloride in the table salt. Okay, table salt, sodium chloride. So the sodium metal is present. So in the sodium metal, it can be cut with a knife. So next one is the melting point and boiling point. So the metals is high melting and high boiling point. Okay, high melting and high boiling point. So high temperature, the metal is melted in high temperature. So in the exception of gallium, mercury, sodium and potassium. Then density. So the density is high density. The metals have a high density. Its exception of sodium and potassium are less dense than water. Then ductility. So the ductility is the metal, in other words of, they can be drawn into thin wire without breaking. Thin wire without breaking. So the wire is very strong. So without breaking is the ductility. Malleability. So the malleability, metals are usually malleable. They can be thin sheet. They can be made up of thin sheet. So without the cracking, they except the zinc and mercury. Then the conduction of heat and electricity. Metals are good conductors of heat and electricity. For example, silver and copper. So exception of tungsten only. So next one is the solubility. So the solubility is metals do not dissolve in liquid solvent. Okay, metals do not dissolve in liquid solvent. So these points are physical properties. These points are physical. The physical properties is physical state, lusters, hardness, melting point and boiling point, and density, ductility, malleability and conduction of heat and electricity, and solubility. So the next one is the physical properties. So in the physical properties, first point is valence electron, then formation of ion, discharge of ion, atomicity and nature of oxide. So first one, valence electron. So the valence electrons means the atoms. Okay, one of the atom is moving around the electrons. Okay, so the atoms of metal have one, two or three electrons in their outermost cell. For example, hydrogen in the outermost cell is only one electron. Helium, the outermost cell is only 2 electron. Okay, so the lithium, the outermost electron is 3 electrons. So the metals usually have 1, 2 or 3 electrons in their outermost shell. Then the formation of ions. So the formation of ions is positive ions is loss of electron. Okay, positive ions means loss of electron. Negative ions means gain of electron. Okay, so the positive ions means loss of electron, negative ions means gain of electron. So this is the ion formation. Ions means positive or negative ions. So this positive ions by the loss of electron is the electropositive. Okay, then the negative ion means gain of electron or electronegative. Then the discharge of ion. So the metal are discharged at the cathode during the electrolysis or their compound. Okay, so the compound means 2 or more metals are present. So in the cathode during electrolysis reactions, so in the discharge of metal ions. Then atomicity. So the molecules of metals in their vapor state are usually monoatomic. So the monoatomic or diatomic or triatomic molecules, the atomicity of present in the chemical properties, the metals in the vapor state. Okay, vapor state. Then nature of oxide. So the oxide of ores are usually basic. So the metal is react with the air, the metal is converted into metal oxides. So the oxides of metal are usually basic. So the next one, extractive metallurgy of aluminium. Okay, extractive metallurgy of aluminium. So the aluminium is the metal found most abundantly in the earth crust. So the aluminium is the more reactive metal. Aluminium is the more reactive metal, is the combined state of metals. So for example is the bauxite ore. So the bauxite ore formula is Al2O3 into 2H2O is the bauxite ore formula. So the bauxite ores is separated to the aluminium metal. The first point is conversion of bauxite into alumina. Okay, conversion of bauxite into alumina, Bayes process. So this is the important question, Bayes process, the conversion of bauxite into alumina. Okay, so in this method, the conversion of bauxite into aluminium metal, the bauxite ore is finely powdered and heated under pressure. Okay, the bauxite ore is finely powdered and heated under pressure with a solution of concentration is caustic soda. Caustic soda is 150 degrees Celsius. Obtained sodium meta-aluminate. So in the equation is Al2O3 plus 2NaOH. Okay, NaOH. So aluminum oxide, then sodium hydroxide to form sodium aluminum oxide. Okay, sodium aluminum oxide, and then water is removed. On distillating the sodium meta-aluminate, in the further reaction, so the sodium aluminum oxide is treated with water, react with water, then the aluminum hydroxide, in the presence of aluminum hydroxide, then sodium hydroxide is product. Then the last step, the precipitate is filtered, washed, dried is the 1000 degrees Celsius to get aluminum. So the aluminum hydroxide to aluminum hydroxide, in the presence of heating 1000 degrees Celsius, the product is aluminum oxide and 3 H2O. So aluminium, the balancing the equation, aluminium 2Al OH3. Okay, so in the 2 into 3, so totally 6 hydrogen, and in the bracket is O, so only 3 oxygen and 6 hydrogen. Okay, 3 oxygen and 6 hydrogen. So in the H2O is 3 into 2 6 hydrogen and 3 is common, so 3 oxygen, then remains Al2. Okay, Al2, then O3. So this is the conversion of bauxite into alumina. So the bauxite is Al2O3. Aluminium to bauxite. Okay, so in the next one, electrolytic reduction of aluminium is the Hall's process. So the first one is the Bayer's process, conversion of bauxite into alumina. Then the Hall's process, electrolytic reduction of alumina. So the aluminium is produced by the electrolytic reduction of fused alumina Al2O3 in the electrolytic shell. So the anode and cathode reaction. Then electrolytic. Okay, so in this picture 8.10, so the cathode is ion tank linked with the graphite. Then anode is a bench of graphite rod is suspended in molten electrolyte. Then the electrolyte is pure alumina. Okay, then fluorspar, then molten cryolite is the electrolyte. Then the temperature is 900 to 950 degrees Celsius, and voltage is used to 5 to 6 volt. Then overall reaction is 2Al2O3 bauxite. So the bauxite is Al2O3. 2Al2O3 gives 4Al plus 3 oxygen, 3 O2s, totally 6 oxygen. So in this reaction, to aluminium in the common number 2, then Al2, so 2 into 2 is equal to 4, so 4 aluminium is in the product, 4 aluminium. Then oxygen, that number is 2 is common, then 3 oxygen, so 2 into 3 is 6 oxygen, so 6 oxygens are present, so 4 aluminium and 6 oxygen. So the balancing the equation, the bauxite to aluminium. So the aluminium, the cathode, the aluminium is deposited at the cathode, and the oxygen gas is anode. So the oxygen combines with graphite to form carbon dioxide. The next one, physical property and chemical properties of aluminium. So the physical properties of aluminium. Aluminium is a silvery white metal. And it has low density and is light particle. It is malleable and ductile, and it is a good conductor of heat and electricity, and its melting point of 660 degrees Celsius. It can be shiny, attractive the appearance. Shiny, it can be polished to produce a shiny, attractive appearance. Then the chemical properties of aluminium. So in the chemical properties, the reaction with the air is the aluminium metal in the presence of air. Air is present in oxygen, so aluminium is reacted with oxygen to aluminium oxide. Then aluminium react with nitrogen to form aluminium nitride. Okay, So the aluminium is not affected by dry air. Aluminium is not affected by dry air. Then the heating 800 degrees Celsius, aluminium burns very brightly form of oxide and nitride. So the aluminium is react with oxygen to form aluminium oxide, then aluminium is react with nitrogen to form aluminium nitride. Then the reaction with the water. So water does not react with the aluminium due to the layer of oxide on it. So the aluminium is react with the water, Al 2Al plus 3H2O. Then the product is aluminium oxide, Al2O3. Al2O3. So this reaction is reaction with water. So in the presence of air, reaction with air means oxygen, nitrogen. Reaction with water is H2O, water molecule. Then reaction with alkali. The alkali is alkali metals and alkali earth metals is lithium, beryllium, sodium, potassium, magnesium. So these are the alkali metals. So is the strong caustic alkali forming the aluminate. So Al aluminium, then react with the sodium hydroxide, then reaction added with water. So aluminium is added sodium hydroxide, then added water to give the product is sodium meta-aluminate. Sodium meta-aluminate is the formula is NaAlO2. NaAlO2, sodium meta-aluminate. Okay, so the reaction with the alkali aluminium is react with the sodium hydroxide and added water to give the product is sodium meta-aluminate. Sodium meta-aluminate formula is NaAlO2. Okay, then reaction with the acid. So the acid like hydrochloric acid, sulfuric acid and nitric acid. So hydrochloric acid is HCl, sulfuric acid is H2SO4 and nitric acid is HNO3. So this first reaction is HCl reaction, hydrochloric acid. Okay, hydrochloric acid. So aluminium is react with the hydrochloric acid to give the product is aluminium chloride. Okay, aluminium is react with the hydrochloric acid, give the product is aluminium chloride. Then the second reaction is sulfuric acid. So the sulfuric acid is H2SO4. Okay, H2SO4. So aluminium is react with 3H2SO4 to give aluminium sulfide. Okay, aluminium sulfide AlSO4 3. Then aluminium react with the 6H2SO4. The product is Al2SO4 3. So in the further water molecule and sulfur dioxide gas is evolved. Okay, remove the water molecule and sulfur dioxide gas is evolved. Then as reducing agent, so the reducing agent iron oxide. So in the iron oxide is Fe2O3 is react with aluminium. To give the product is ion is separated the ion metal and bauxite Al2O3. In this process is aluminothermic process. This process is aluminothermic process. So iron oxide is added aluminium to give the product is iron and bauxite. Next one, the uses of aluminium. So in the uses of used aluminium is household utensils and electrical cable industries, and then making aeroplanes and other industrial machine parts. Okay, other industrial machine parts. So today we are see about metallurgy separation process and their metals properties, physical property and chemical properties, and the extractive metallurgy of aluminium is the Bayes process and Hall's process, and the aluminium physical property, chemical property, and their uses. Okay, so now your homework, all of you study and write. Okay, study and write in the aluminium. Okay, aluminium Hall's process, and then aluminium uses of aluminium, and then Hall process. And one more question is the fourth flotation method. Okay, those are three questions. What is fourth flotation method, and Hall's process, and then uses of aluminium. Okay, so all of you study and write your homework note. Okay, thank you children.